right, so now we're going to talk about specific volume, pressure, and temperature. So specific volume, we've talked about already. It's the inverse of density. So instead of being in kilograms per meter cubed, it's going to be in meters cubed per kilogram. Why do we prefer specific volume versus density? It's just a matter of convenience. Some gases are going to have really low density, so rather than messing with a low density, maybe we want to mess with specific volume instead. So again, it's just a matter of preference. Regarding temperature, we've talked about the units that we're going to use. You might wonder, where does that 273 come from? Where does that conversion factor come from? Did they just make that up? It actually corresponds to the triple point of water, which is 273.15 Kelvin, or 273.15 Kelvin, but it's actually also defined by pressure as well. So the triple point of water occurs at 273.15 Kelvin and about 0.6 kilopascals, 0.6 and change, 0.611 and change kilopascals. So I'm going to play a video. Let's go ahead and play that here. So the triple point is what you're going to see is all three phases, liquid, vapor, and gas. Liquid, solid, and gas, all coexisting at the same time in equilibrium. And again, this happens at 273.15 Kelvin and 0.61 kilopascals. So what you could see here, I'm gonna pause it here. So you could see like there's ice here. Don't worry about the marbles. These are just serving as sites of nucleation for the ice crystals. But what you'll have, you have ice, you have liquid, and what you'll see is actually gas bubbles. You'll see boiling within that gas. So I'm going to continue. You could see it here, but yeah, oops. Yep, there we go. So you can see, there we go. So you see some bubbling here, but you also see ice crystals, and there's liquid there as well. So all three phases are existing at the same time. If you change temperature or you change pressure from 273.15 and 0.611 kilopascals, then you're going to get rid of one of those phases or maybe two of those phases. All right, so I mentioned also that if you're going to be dividing by or multiplying by a temperature, you need to put it in absolute temperature units. One little caveat: a change in degrees Celsius and a change in Kelvin is going to be exactly the same. So if you 100-degree temperature change and 100 Kelvin change, a temperature change of 100 Kelvin, it's going to be the exact same. Why? Well, because you're looking at a difference, right? So let's use 25 degrees Celsius. So 25 minus 0 degrees Celsius, you get a 25-degree temperature change. If I put it in Kelvin, well, 25 degrees Celsius is 298.15, or I'd probably round that off to 298, but 298.15. 0 degrees Celsius is 273.15 degrees Celsius. It is still a 25 Kelvin temperature change. All right, so there's temperature. Pressure. Pressure is pretty self-explanatory, right? All system properties have to be evaluated at the absolute or the system pressure. So this is going to be different from gauge pressure and atmospheric pressure. And it's going to be dependent on both of those. Atmospheric pressure we're going to take as 1 atm or 14.7 psi. So you could see over here I've got 14.7 psi. It's psi-A. So if you see an A there, it means it's absolute. It's the system pressure. Gauge pressure is, well, self-explanatory. It's what you're measuring. And so if you had to evaluate the properties of the air in your tires, for example, you would be evaluating it not at the gauge pressure, but at the absolute or the system pressure. All right. So that's all I got. Thank you for watching. Let me know if you have any questions.